Today we're going to look at different kinds of problems that deal with the angles we've learned about. Our first two examples combine geometry, algebra, and a picture. If we look at example 1, 6x minus 10 degrees is referring to this angle, and 2x plus 30 degrees is referring to this angle. So how do we solve for x in this problem? Well, we first have to identify how these angles are related to each other. If we look, these two angles are adjacent and they form a linear pair, which means that they are supplementary. So the algebra that we're going to set up is this angle plus this angle equals 180 degrees. 6x minus 10 degrees plus 2x plus 30 degrees equals 180 degrees. Combine our like terms. 6x plus 2x gives me a grand total of 8x. And adding my degrees, I have negative 10 degrees plus 30 degrees. Gives me a grand total of positive 20 degrees. Solve for x by subtracting 20 degrees from both sides. And then divide both sides by 8. So x equals 20 degrees. So how big is each angle? Well, we need to take that 20 degrees and plug it into x. 6 times 20 minus 10. This angle right here is 110 degrees big. Our second angle is 2 x's, 2 times 20 plus 30. 70 degrees. Now, are these two angles supplementary to each other? Yeah, total, they add up 180 degrees. This is a good way to check to make sure you have the correct answer. In our second example, we have the exact same picture, and we actually have the same algebra for the angles. But if we look, these two angles are not supplementary. They're across from each other, where two lines intersect, which means that they are vertical. And vertical angles are congruent. So the equation that we need to set up is 2x plus 30 equals 6x minus 10. And solve for x. I'm going to subtract 2x from both sides. And add 10 to both sides. And finally divide by 4. So x equals 10 degrees. To check that answer, again I plug 10 in for x. Our first angle was 2 x's, 2 times 10, plus 30. Our second angle was 6 x's minus 10. 6 tens minus 10. And if you look, both angles are 50 degrees, so they are congruent. In an example like 1 and 2, we need to first figure out how the angles are related, then set up an algebraic equation based on how the angles are related to each other. In example number 3, we have a word problem. Two angles are complementary. One angle is twice as big as the other. What are the measures of each angle? Our first sentence is our first equation. We know what complementary means. It means sums to 90 degrees. So if two angles are supplementary, we can't just say x plus x equals 90 degrees, because the two angles could have different measures. So we need two variables, like x and y. I can pick any two variables. I just picked x and y. Two angles are complementary. This is our first equation from this first sentence. Our second sentence is our second equation. One angle is twice as big as the other. We'll start with one angle. I'm just going to pick x. Is becomes equals twice as big. The operation twice as big is multiplication times 2. So if we are twice as big as the other angle, one angle, x, equals 2 times the other angle, 2y. So how do we combine these two equations? Well, we need to do substitution. How big is x? Well, x is 2y big. Anytime that I see x, I can plug x in to another equation. If I combine these two equations, substituting in 2y for x, I end up with 2y for this x plus y equals 90 degrees. Once I've written both equations and substituted into the other equation, I only have one variable left, and I can solve for that variable. 2y plus y equals 3y. I can combine my like terms. Divide by 3, divide by 3. Y equals 30 degrees. Well, I need to find the measure of each angle. So I need to figure out how big x is. If y is 30 degrees, I can use this equation to solve for x. X is 2 y's. Well, each y is 30 degrees, so x is 60 degrees. The measures of the two angles are 60 degrees and 30 degrees. Together they equal 90 degrees. They're complementary. And one angle, x, is twice as big as the other. The fourth example is looking at how angles relate to each other in a proof. If we look at our given angle AOC, AOC, and BOD, BOD are straight angles. These angles form straight lines. We need to prove that angle AOB is congruent to angle COD. If you look, these two angles are vertical to each other. So in essence, this proof proves that vertical angles are congruent. Step 1. These two angles are straight angles. That's my given. And what do we know about straight angles? Well, if we measure a straight angle, its measure is going to be 180 degrees. So the measure of AOC equals 180 degrees, and the measure of BOD equals 180 degrees. Since straight angles measure to be 180 degrees, that's their definition. The definition of straight angles: if angles are straight, then their measure is 180 degrees. Looking at step 3, now I have these two angles, their measures being equal to each other. Well, if they both equal 180 degrees, they're going to be equal to each other. So how do I combine these two statements into one? Well, if I look, any time that I see 180 degrees, I can replace it with the measure of BOD. So I can replace this 180 degrees with BOD. I've really substituted. And I've substituted 2 into 2. I could have also said the transitive property here, but I like to think of this as substitution. Now let's look at step 4. We have something completely different here. If we look at our picture AOB plus BOC equals AOC. If we look, we have angle plus angle equals bigger angle. That is the angle addition postulate. And if you look at step 5, angle BOC plus COD equals BOD. BOC plus COD equals BOD. Angle plus angle equals angle. That is also the angle addition postulate. Now the next step looks very confusing. A lot of you, whenever you are confused in a proof, like to just put down substitution. Well, this step actually is substitution, but it's important to figure out where am I substituting? How do I get this step? If you look at the left side of the equation, it matches up with the left side in step 4. But the right side is different. AOC has become BOD. Can I exchange AOC with BOD? Yeah. Step 3 says I can take BOD and replace AOC with BOD. So if I take step 3 and I substitute into step 4, I create step 5. Now going on to step 7, the left side of my equal sign hasn't changed, but the right side has. Angle BOD has become angle BOC plus angle COD. Can I replace BOD with BOC and COD? Yeah, step 5 tells me that. I can substitute step 5 into step 6 to create step 7. Now I've done all of this work to get to this point right here. I have an equation, and on both sides of my equation I have the same angle. And since I have the same angle on both sides, I can subtract off that angle. If I subtract BOC from the left side and from the right side, I'm left with just angle AOB on the left and angle COD on the right. To go from step 7 to step 8, I need to subtract angle BOC. And finally, if two angles have the same measure, then those two angles have to be congruent. Why this extra step in here? Well, that's what I'm trying to prove. I need to prove that the angles are congruent, not that their measures are equal. So to go from two angles having the same measure to those two angles being congruent, that's the definition of congruence. The definition of congruence allows me to switch from an equal sign to a congruent symbol.